We're going to finish up lesson 2.3, so get out your note sheet how we did the previous lesson, and let's turn to the back. So we practiced some long division and synthetic division yesterday. So today we are going to talk about the remainder theorem and the factor theorem. So the remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder r is the same as f of k. So in other words, you can use synthetic division to evaluate functions, and the remainder gives the value. All right, so this seems kind of weird to you guys probably because you always kind of had calculators to use, but before there were calculators, if we wanted to take this function 4x cubed plus 10x squared minus 3x minus 8 and find f of negative 2, we would have to plug negative 2 in for your x's, cube, multiply by 4, square it, multiply by 10, multiply by negative 3, and then add all those together. So you start getting kind of big numbers, and it's not real conducive. But somebody figured out that you can do synthetic division where all you're doing is multiplying and adding. You never have to cube things, you never have to square things, and it goes a lot faster. So what you do is called synthetic substitution, and you set up synthetic division. But it's because we aren't technically dividing, because when we were dividing by something like x minus 6 or x plus 2. We don't do the opposite. We actually take the number that we're trying to find the value of when we plug it in, and you put that number in the box. All right, and then we bring over our coefficients in our constant. Now on this one, nothing was skipped, so we didn't have to fill in any zeros. And then we do synthetic division by multiplying and adding. All right, and then whatever the remainder is, that's what f of negative 2 is, 6. So that's the same thing we would get if we had plugged negative 2 in for the x into the function. So it's pretty quick when you can't use a calculator at all. All right, we can do it for fractions also, so don't get too panicky. We're just going to put 1/2 in the box. All right, then we bring down the 4, multiply by 1/2, add, multiply by 1/2, add, and then this is where it gets kind of messy. Because we do have to add negative 8 and 3/2, which means we need negative 8 to be a fraction with 2 as the denominator. So it's going to be negative 16/2. So negative 16/2 plus 3/2 is negative 13/2. All right, so what that means, and I don't have a lot of room, but that means that f of 1/2 is negative 13/2. The remainder is the value of the function when x is 1/2. That's the remainder theorem. All right, and then the factor theorem is all about when you have a factor of the function. So the factor theorem says a polynomial function f of x has a factor x minus k if and only if f of k equals 0. So in other words, you are going to do synthetic division or just regular long division, and the f of k is a factor if you do the division and you get a remainder of 0. And that makes sense. When you divide something by a factor of it, there is no remainder. It divides evenly. Okay, so this is going to be a 3-part question. Now I have the directions that are in your book. This is an old note sheet. We are not going to do the E part. So when you guys go to do your assignment, you're also not going to do the E part because we're not going to use the calculator. We could to check, but we're just not going to do that today. So for the A part, we're going to verify the given factors of f of x. So to verify those, we're going to do synthetic division and show that you get a remainder of 0. Now this is different than what we just did. And what we just did, it wasn't written as x minus something or x plus something. It was just f of -2. So you put -2 into the box. This we have x minus 5. So that's when we're going to use the opposite, whatever makes that 0. All right, then we'll do our coefficients and our constants and do synthetic division. All right, this is good. So when we end up with a remainder of 0, you have verified that factor. Now we need to verify the other factor, and we're not going to go back to the original problem. So as long as you get a remainder of 0, you can use something that's called the depressed polynomial, that we can just use these coefficients, and then that becomes the constant. And do synthetic division with this, and then make sure we get a remainder of 0. And we do again. Right, so that's the A part. Verifying the factors means dividing and getting a remainder of 0. All right, the next thing we're going to do is to find the remaining factors of f of x. So what we want to do is write this as a new polynomial. So what we'll do is just kind of think about it. So if we do synthetic division one time, it's going to go from x to the 4th to x to the 3rd. And then when we do synthetic division another time, it's going to go to x squared. All right, so we'll take this polynomial and factor it. And that should give us the remaining factors. That's what it's asking for on the B part. All right, on the C part, we're going to use your results to write the complete factorization of f of x. So we'll say that f of x equals these factors we found multiplied together times the factors we were given. And if you wanted to, you could take all those and multiply them out, and it should give you that original function. All right, and then the very last one we're going to do is D. We're not going to do E, like I said. We're going to list all the real zeros. So when you're given the factors, you can find the zeros really easy. So if x minus 2 is a factor, 2 is a 0. 1 is a 0. 5 is a 0. And -4. Those are your 4 zeros, 4 real zeros to that function. Okay, so we're going to do the same directions on this second function, but it's going to be a little different because the factors are given in a form where we cannot use synthetic division because they both have coefficients on the x's. So that's okay though. We know how to do long division. So what we'll start with 2x plus 1. We're going to divide it into our function. All right, so we'll start off with our divide step. And then our multiply step. And then subtract. And then bring down. And start all over. remainder 0, check. All right, and then what we'll do is take this and divide it by the other factor. Right, again, because a factor has a coefficient of 3, we can't do synthetic, we have to do long division. All right, so we have verified both of those. All right, when we go to do the B part, it asks to find the remaining factors. Well, the only thing we have left is this x plus 7. That's your remaining factor. All right, and then for C, I'm going to have to go under here. For C, we're going to write the complete factorization. So we have the factor we just found, and then the 2 factors we were given. All right, and then for D, the 0, so -7, -1/2, and 2/3. All right. So what I want you guys to do is page 144 through 145, 1, 4, 5, 6, 48, 56, 61, 68, 70, and 72. Now on this 68 through 72, only do A through D. So omit the part that is E. Also, on number 61, be careful on that one. So you're given something like x equals 1/2. And it's one where you're finding the factors and the zeros, and one of the zeros is 1/2. Don't forget that a factor that would give you 1/2 is the factor 2x minus 1. So you are going to have to do long division. So I think when you see that problem, if you write yourself a note, you'll know what to do. And I wrote another note on the direction or on the answer, so hopefully that will help.